perform the indicated operations, then simplify. So we have three rational expressions here, and we're going to subtract this one, and we're going to add this one. So just like if we were adding and subtracting a bunch of fractions, we really have to find a common denominator here. And to figure out a common denominator, we have to figure out the least common multiple of x plus 5, of 2x minus 10, and x squared minus 25. And to find the least common multiple, we really want to factor these out and make sure that that least common multiple, that common denominator, has all of the constituent factors in it. So this can't be factored anymore. X plus 5, that's about as simple as you can get it. 2x minus 10, we can factor out a 2, and it becomes 2 times x minus 5. So we factor that out. And then x squared minus 25, you might recognize as a difference of squares. So that's the same thing as x plus 5 times x minus 5. Just factored that out. And so if we want to have a least common multiple, so let me rewrite each of these with that common denominator here, that the least common multiple. The least common multiple is going to have to be something that has x plus 5 in it. It's going to have a 2 in it. It's going to have an x minus 5 in it. And and we've already said it has to have an x plus 5 and an x minus 5 in it. So it's got to have a 2. It's got to have a 2. It's got to have an x plus 5. It's got to have an x plus 5. It's got to have an x minus 5 in it. It's got to have an x minus 5 in it. And it's got to have an x plus 5 times an x minus 5. Well, we've already got that there, so no need to write it again. So that right there is our common denominator. So let's write it out. So let's rewrite each of these expressions with that common denominator. So 2 times x plus 5 times x minus 5. And then right over here, I'll write it again. 2 times x plus 5 times x minus 5. Once you get used to this, you might be able to just write out the common denominator once and then figure out the appropriate things to multiply the numerators by. But I want to make sure we go through every step for these videos just so we make sure we understand what's going on. So to go from x plus 5 to 2 times x plus 5 times x minus 5, what do we have to multiply x plus 5 by? Well, we have to multiply it in order to get this. We're multiplying it by a 2. We're multiplying the x plus 5 by a 2, and we're also multiplying it by an x minus 5. So if we're multiplying the denominator by a 2 and an x minus 5, we have to multiply the numerator by a 2 and an x minus 5. So if we multiply 2 times x minus 5 times 1, we'll get 2 times x minus 5. And we don't even have to write this 1. Now we're subtracting over here. And to get from 2 times x minus 5 to this over here, what did we have to multiply it by? Well, we have the 2 times x minus 5 right over there. We had to multiply it by an x plus 5. This is the part that is new. We had to multiply it by an x plus 5. We have to multiply this denominator right here by x plus 5 to get this denominator. So if you multiply the denominator by x plus 5, you want to multiply the numerator by x plus 5 as well. So the numerator is going to be 2 times x plus 5. Just took the 2, multiplied it by x plus 5. Exactly what we did to the denominator. We multiplied it by x plus 5. Then we have this last expression right over here. We went from, let me do this in a new color. We went from x plus 5 times x minus 5 to x plus 5 times x minus 5 times 2. So to go from this denominator to this denominator, we just have to multiply by 2. If you multiply the denominator by 2, you should multiply the numerator by 2. So multiply 2 times 2x, you're going to get 4x. So all I did here is I multiplied it by 2. Let me make it clear. To get from this to this, I multiplied it by x plus 5, and then to go from there to there, I multiplied it by 2 times x minus 5. And over here, I should use, instead of writing multiplied by 2 right there, I should multiply by 2. I don't want to get the multiplication symbol confused with the x variable. And of course, there was a positive out here. So we are now ready to do our adding and subtracting. And we could view this, just for simplicity, just make it clear. Subtracting this thing is the same thing as adding the negative of it. And that makes it a little bit simpler. So let's put our common denominator down. Let's put our common denominator down. So all of this business is going to be in our denominator is going to be 2 times x plus 5 times x minus 5. And our numerator is now going to be, and I'm going to multiply this out so that we can properly add terms. So 2 times x minus 5 is 2x minus 10. And then we have a negative 2 times x plus 5. So that's going to be negative 2x. And the negative 2 times 5 is negative 10. And then we're going to have a plus 4x. Plus 4x over here. Plus 4x. And then we can simplify this thing. And so you have a 2x. You're subtracting a 2x. Those guys cancel out. Then you're left with just a 4x. So you're left with just a 4x, and then minus 10 minus 10. So 4x minus 20 over 2 times x plus 5 times x minus 5. And then, let's see, we can factor out a 4 up here. So if we factor out a 4, this becomes 4 times x minus 5. And then if we assume that we're not dealing with x is equal to positive 5, because that would make the denominator undefined, we can divide the numerator and the denominator by x minus 5. And so if we divide the numerator and the denominator by x minus 5, those cancel out. And we could divide the numerator and the denominator by 2, since they're both divisible by 2. That 4 divided by 2 is 2. 2 divided by 2 is 1. So in the numerator, we're just left with a 2. And in the denominator, we're just left with an x plus 5. We're just left with an x plus 5. Now, I want to be very careful here. Because this expression up here, if we really want this final answer that we got to be truly identical to this expression over here, just a simplified version, we have to make sure that it has the same domain. If, say, this was part of the function definition, you want to make sure that it's valid for the same x's, and not anymore if you want them to be truly identical. And this up here is not valid. So the domain, if you viewed this as one entire expression or one entire function definition, the domain would be all real x's except x is equal to, x cannot be equal to negative 5, or x cannot be equal to positive 5, because that would make this denominator equal to 0, or x is equal to 5. And so if you want these two things to be identical, they have to have the same domain. If you want them to be, most algebra classes, people will not be particular about this. And maybe you don't want them to be the same function. Maybe you want maybe you want it to be defined when x is equal to positive 5. But if you want them to be truly the same expression, you have to have the same domain. So you could, your domain, you would want to say it is all real x's except, if you were to just do the domain for this thing, if you just saw this expression right here, you'd say, OK, x can't be equal to negative 5. But if you wanted to have the same domain, so let me write, except x is equal to negative 5 and x equal to, and so this right here is just a domain for this thing. But if we wanted to have the same domain as the original expression, we would also throw in and x is equal to 5.